At times, you may need to find the shortest path from one node to another. It might be the shortest distance or even the shortest time from one node to another. Earlier, we looked at finding the shortest path by identifying all the possible paths and then adding up all the arc lengths and then choosing the shortest one. As networks become more complex, this method will be impractical as it would just take far too long. We're going to need to use a different method. A method we can use is called the shortest path algorithm. In this diagram, we're trying to get from A to P in the shortest possible path. And as you can see, looking at all the possible ways to get to P, it would just take you far too long to write them all out. So one thing you can do is draw or redraw your network diagram with the labels outside the nodes to give you room to write the times and distances on the inside. And from there, you just follow these steps, okay? For all the nodes that are one step away from A, write in the shortest distance. So if this is A, one step away is B, and that is 2. The next node that's one step away is E, and I can see that that is 3 away. So that's all the 1 steps taken care of. Now I need to look at the 2 steps. In this case, we've got A to B to C. So if I arrive at C, going this path here, 2 plus 2 equals 4. If I go down to I, it's going to be 3 to E, and then a further 5 to I, so 3 plus 5 equals 8. Now F, there's 2 different ways I can get to F. I can go A to B to F, and that's going to take 2 and 3, which is 5. Or I can go this way, which is going to be 3 plus 3, which is 6. Now out of those, this way is shorter. 2 plus 3, which gives us 5. Now that's all the 2 steps taken care of. What you need to do is you need to repeat this process until we get down to P. After you've reached your final destination, you have calculated the shortest distance. In this example, the shortest distance is 14. To find the path that you've traveled, you need to work your way backwards. To do this, you take the node and then you subtract the arc length. If the result is equal to the next node, that is the path you've taken. So I'll show you what I mean. Here's 14. An arc length here is 3. 14 minus 3 does not equal 12, so we haven't traveled down that path. 14 minus 13, 14 minus 1 equals 13. So that's the path we've taken. Now, we're here. 13 minus 5 does not equal 9, so we haven't gone that way. 13 minus 2 equals 11. So this path here, 11 minus 9, 11 minus 2 equals 9. 9 minus 4 equals 5. 5 minus 3 equals 2. And then 2 minus 2 equals 0, which gets us back to our starting point. So the shortest possible path, I've indicated in yellow, and the shortest distance is 14.